Hey, hello and welcome to this LangChain tutorial. So in this video, we'll cover a very important topic in LangChain, which is LangChain Expression Language and how you can create pipelines using LangChain Expression Language. So thing is, when you create a generative app, right, using LangChain, so if you see, it is essentially a sequence of events and which can be separated using a pipeline. I mean pipe symbol. So you can execute as a pipeline where events are separated using pipe symbol. So whatever example we have also done, if you see, right, what we have done is we have a prompt, we feed that to model and we get an output. From that we extract the content. So if you see, there are three events, right? Prompt, which is fed to model to get the output, which is then parsed to get the content out of the response. So that if you want to do as a, let's say, same thing, right? Prompt model, and actually there is a class called uh, output parser. There are many classes actually within output parser. So there is one str output parser which helps with parsing the output, right? You can extract the text content out from a model message. So suppose you have these three events. So with the LCEL, how you create a pipe is like this. You can create a chain of events: prompt separated by pipe, then your model, and then output underscore parser, which is a object you get from str output parser class, and that you get as a chain. So just as an example, that's how you can create a chain using LCEL, a simple chain. So what happens actually when you have these events? So each event actually in LCEL is of type runnable, which gives you automatic support for both synchronous and asynchronous, as well as for streaming and also for parallel execution. So all that you get built in through LCEL, because then each event becomes of type runnable. So that is some basic about LCEL and how you can use it to create workflows. So when you compose chains like this, right, you have prompt, model, and output parser separated by pipe symbol, and you get a chain. So this signifies the flow of information from left to right, right? That your prompt that is feeding its output to model, which in turn is feeding its output to output underscore parser. And from that, it will parse the content out of your response from the LLM and you get the output. So that is one simple chain, how you compose a workflow using LCEL. Same way you can create complex workflows also. So as an example, suppose you have the user query that you send to the LM to reformulate that query. Then using that user's query, you search the vector store to get the relevant data. So you do a search query. Then using, so what I'm talking about is kind of a RAG workflow, retrieval or augmented generation. Then whatever data you get from your vector store, that again you send to the LLM to summarize it. Then using that summary and the user's query, again send it to the LLM to get the final answer. So you can have that kind of workflow also, which can be written something like this. So if you see, you have these pipes separating the workflow, and in turn again you have workflow here separated by pipe symbol. So you can say within pipe you have nested pipes, right? So that's how you can create complex workflows. I'm not going into much detail right now, so we have just started. So let's start with some simple example first. And as I said in the lesson 1, maybe by end of this whole class you will be able to create such workflows easily. So that's the aim actually. So coming to features of LCEL, so first thing, as we have already discussed, every event is a type of runnable object, right? So with that you get some methods inbuilt, because the runnable object, that means there is a class already written in LangChain which gives all these methods. So some of the key methods are, you can use invoke or a invoke. So if you see, each method as a another method which starts with a. So whenever it starts with a or prefixed with a, that means it is a synchronous counterpart of the same synchronous method. So invoke is same thing. If you invoke the chain dot invoke, when you call, it will go through the whole workflow, take your input, insert it in your prompt, then you will invoke the model and get the output. Parser will give you the parsed output. So from input you get to the output. Same way you can run batch method. So it is like running as a batch. So same chain, you give it, you pass multiple inputs to it and you get multiple outputs. So you can run it as a batch operation. Then there is also streaming. So you can also stream data, stream the output actually. So you don't have to wait for the whole chain to finish and get output at the end. It can stream output. Then you also have a stream underscore log, which actually does logging also of intermediate steps. So you have output which is streamed, and how you reach to that output, all that is also logged. So that is why you have log in between. Then it uses pipe symbol that we have already seen. So you use pipe symbol dividing the events, which creates an explicit left to right data flow. Then, as we just saw, you have async support. So by default, all LCEL chains are asynchronous. That means they'll run in background. So you have other tasks that will also carry on their work. So it is not blocking for the model's response. That is the idea. Then you have also streaming. So if there is a large output you are getting back, then you don't wait for that output that everything is finished, then only you will get the entire output. It can stream data also. So you'll get pieces of response as chunks, which you can then loop, and you keep getting those streams. And parallelization. So you can run events in parallel also, as in if they are independent, right, then only it will make sense. If one event is dependent on another event, of course it will be not feasible to run them in parallel. But if there are some independent steps, then you can run them in parallel. So for these parallel, batch, so there are some classes which are provided. So what happens is with LCEL, now we have some different classes. Initially, with previous versions of LangChain, actually, there were some other classes like LLM chain or sequential chain, which are now deprecated. So now you should create your workflows with newer versions of LangChain only using LCEL. And it also gives you some runnable classes. So we'll go through that. We'll see what all runnable classes are there. So if you are creating a sequential chain, which is equivalent to what we saw in the beginning, right? A sequential chain, prompt, model, output, parser. If you want to do the same thing explicitly using a class, then there is a runnable sequence which can do the same thing. Though using pipe is simple, but there is a runnable sequence also, which this pipe is actually you use the term, right, syntactic sugar over this runnable sequence. Then there is parallel chain, when they can run as independent steps in parallel. For that, there is a runnable parallel class which can do this job. Then you can also have conditional chains, right, where based on condition it may branch to different flows. So for that, there is a runnable branch class. And you can also use your custom Python functions within a chain, so that you do using runnable lambda. So we'll discuss all these classes in detail with examples in separate videos. But first, let's try to create a simple chatbot. So that's what we'll try to do, create a simple chatbot, which is like a hello world for LCL or LangChain. And we'll also use Streamlit UI to create a UI for that chatbot. So to do that, what we have to do is again I have created a new folder. That's where I'll create a file, chatbot.py, and requirements. I already did this Streamlit. We did one example, right, where we used for code generator. So there I have already installed this. If you have not done, you have to add it in requirements.txt and run pip install minus hyphen r requirements.txt. So that Streamlit is also installed as a package. Then coming to this chatbot.py, we'll have some imports. So let me put view wrap. All right, so we'll again use chat prompt template, and as a model I'm going to use chat Google Generative AI. You can use any other model also if you want. There is str output parser to get the parsed output, and Streamlit. Then this is the system message, that you are a helpful assistant that responds to user queries. Then this will be the query which you will inject. So we have created the prompt also using chat prompt template from message, which gets that list of system message and human message, which will be getting this user input. So what else? We need model. So model will be chat Google Generative AI model equal to, I'll just put some temperature also. It's a 0.3. So I'll be using that Gemini 3.1 flashlight preview. So this will be the model. So model is there, prompt is there. Then we can create a method, say generate response, which will get whatever you are asking. So we can say let's say user query, and it returns that response. So str it will return. So that will be our function generate underscore response, which gets user query. That will send from the UI what you type as a query, that will be sent here, and then you will get the response. So using this, now we can create our chain. So chain will have these things, right? I have to create that parser also. So I can create output parser, which will be a object of this str output parser. So now I have all the things. So I can create prompt by model str output underscore parser. Then we can invoke this chain, which takes a dictionary. So we have to pass this user input, right? So user input, for that we'll pass. So this will be our key, and value will be this. In dictionary, value will be this user underscore query, and that we'll get in response, and we can return that response to our UI now. So these will be the steps in your this function generate underscore response. Now create here itself Streamlit part. So first thing we have to configure, right? We can give title for page, where I can give page underscore title to, let's say, simple chatbot. All right, and I'll keep the layout as centered, not wide. Then we can give the title for our app. So you can use the same thing, simple chat bot. And as we generally do, give some emoji. So in Windows, you can do Windows and semicolon. So that gives me a okay. So we have our page config. So with that, what happens is your tab, right, in Windows browser, that will have this name, layout is centered. So you get in the middle, and this is the title of your app. Then what you can do is, of course, you have to get the user query that you can do using input, st.input, right? That's where you can ask your question. So actually, with the Streamlit, right, you have some chat related components also. So it won't be simple input actually. In that case, right, we can name it chat underscore input. So what is the difference when you see in the here we can just say enter your query. So you'll see that difference. So with chat input, right, you'll get that arrow kind of that you are sending that message. So all that will be automatically there. You don't have to do anything. So when we see the UI, you will notice that. So now we can do what? We have the user query also. So we can just make a condition. If user query is there, then we can send it to, where is our function? Generate underscore response. Generate underscore response. We can send this user underscore query. So I'm just creating the basic workflow first. There are some other steps actually. You have to add the previous chat input output in session state of Streamlit. So that also I'll just do. But first I'm just writing the basic workflow. Otherwise, you can just say st.warning. Please enter your query. So that is kind of basic input, right? So you see, and that response we have to take, then and add it to the. Now we'll get to all this, that how you can add it to session state and get it. So first thing is, when you are starting, so when you write any new thing in your Streamlit UI, it will run from top to bottom, everything. So all the previous messages also you need to store. So for that, actually, you have to keep it in session state. So how you can do it? So suppose I am using a variable named chat history. So first thing you can check if chat underscore history. So first time, not in st dot session underscore state. So if chat underscore history not in session state, then you have to create that variable. So it's a empty list, right? If it is not in state, then you create it in the session state as a empty list. Then what you have to do is you have to add your messages to this session state within this list which you have just created within your session state named chat history. So for that, what you actually do is you add it in with different roles. So for message in, So each message which you have in this list, so that's what with this with, right? With this with, what you do is you create a container kind of for each role, a separate container. So that's how you can group your messages. So if we take two roles, right? User, which is asking the query, and AI, which is answering those queries. So you have two roles. So that's what you can do with st dot. So it has a chat underscore message with st dot chat underscore message. Within that, what you'll do is message. From this message, you will get the role. Not this one. This will be this, right. So for each role, what you need to do is you will have to append it in this. Not append it. Sorry, you have to write it right in the. So you will be using markdown. You will append it later. So st dot markdown. So this message you will write here st dot markdown. This message, and not the whole message actually. From that you will take which part, that will be your content. So content, so message, from that you take the content. So that's how you will get all the previous messages. As I said, for each query when you write, it will run this whole thing. From here it will start again. So all the previous messages, that's what this part will do. So you'll get them in UI, all the previous messages. Otherwise, all the messages will be gone. Now we have this user query. We have done this part also. If user query, that is where we have to actually get it into this list, whatever you have asked, right? So this user query has to be in the list. So that is where you will actually append it to this list. So when you have asked the query, if it is there, then what you do is you will append it to the list. So you can add it as an object with a role and a content. That is why we are getting role and content. So we'll create an object actually with role. This is from user, so role will be user, and content will be this user underscore query, correct? So that is what you are getting, role as user and content as user query. This has to be double quotes. So that is how we have created, added it into the list, which then will be used here. And when you get a response, that also actually you have to append. So let me copy this part only, and we'll make change here itself. So response also, when you get, you will add it to. So let's take it as assistant, in that case, assistant, and content will become this response. So now we have added these two also, and here also actually user query you have to show. So we'll have to do this also. So user query, you add it to this list so that it can be used when you again rewrite all the messages. But when you are typing, that is the time when you need to this query, show this query, that time also, right? So for that also, what you need to do is you have to write it as a markdown. So this will go here, st.markdown user query. So we have session chat underscore history, then we have this markdown. Same thing actually we have to do for response also. So this also will do. And one more thing I'm missing is again setting that container so that you get it as proper role. So when I'm doing this, I can say this role is user anyway. So I can just say here with st.chat message as user, which is this one. So I can put here user. With that, ust.mark down this part. And with this, I can put here also. And here it will be assistant. So that will be your whole code actually for Streamlit. I hope I've got it right. So let me go through everything again. So we have import for whatever we are using here, all the classes. So nothing unusual there. We have already done all this. The only thing new is this str output parser, which is used to parse the content out of this response, which you get from LLM. Then how you get that, this we have already discussed in other lessons. So this is the placeholder here, which has to be replaced by the actual value. So for that part, we'll go to Streamlit, but before that, that's where first time we are creating a chain. So now if you see, right, one thing you have to notice is we are not doing chain.invoke directly. We are not doing prompt.formatting, model.invoke. So everything will be taken care of by this invoke itself. It will come here, prompt, it will do the necessary injection of actual value, then it will invoke the model and parse the output. So everything will be done by this chain itself. So you just define the workflow, right? So you are getting the point what we are doing now with this. We are not doing prompt.format, model.invoke, just prompt, model, output parser separated by pipe symbol, and you invoke that chain itself. And then the Streamlit part. So page config title. Here you have page underscore title. If chat history not in, so we are creating a history, as I have already told you 2 times that you do this because you need to get that whole history. So we'll see it in execution very soon. Then you get the user query. So if user query is there, then again that user query you have to put it in this list, so that next time that also is that also becomes part of this chat history. But you have to show here also when you are typing, so all that you have to do. This is response part. That's where you get here to this function. And that's it. So looks okay. So you have to do Streamlit run /nl3 chatbot.py. Okay, one thing I forgot, which is this. So I'll get that error when we actually invoke this. So I'll do it before itself from .env import load underscore .env and load underscore .env. So we have already got that you don't have the key here. So I saw one more error actually, which is here. Put double quotes here. It will be on the key, not on the whole. So one mistake. With that, if we run again, brings me to the chatbot. It takes some time to load. All right. So here, if you see, we have tab. Right here we have that what we set through page config. Here we have the title, and it is the giving the warning in the beginning itself. Then what we do is we ask our query. So let's say I say explain encoders in neural network in 5 lines, not a lot of data. So that will come as marked down here, and I get the answer. So one thing I want to clarify here, when we are storing in session state, right, that chat history. So that chat history is in the context of here, right? This is in the context of Streamlit only. Our chat itself has no history. So LLM is stateless. That we can check with the, say, what is 5 multiplied by 2. So I send this, should get 10. Then if I say add 5 to this number, right? So it doesn't know. Please provide the number you would like me to add 5 to. It has no idea that we already have some number here. Or if I say, um, my name is, let's say, Jesse. Tell me my name. Right? Saying I don't know your name. So LLM still is stateless. So if you want history in your chat, that has other ways. I mean, there are other ways to do it in LangChain. We'll come to that. But what we have done here, this history, what we have added here, is just for this getting them here. So it is in the context of Streamlit only. It is not your chat history which retains the previous conversation. So just wanted to make that clarification. And that's how you can create a simple chatbot using this chain. So again, as you can see, now it becomes very simple, right? You are not doing any formatting. All those becomes implicit steps. Now you just say chain.invoke and get the what you want to inject here itself. All these flow will be taken care of your LCEL. Thanks for watching the video. Please don't forget to like and subscribe.